Welcome back. Yeah, the sound. I don't wear a microphone right now. You might remember that I moaned a lot about my studio lighting giving up during the heat, but now it even shuts down when you have here a mediocre 25 degrees C. So I will exchange the electronic transformer and maybe we do a teardown and possible repair. Yeah, uh, let's get started and enjoy. And of course, I disconnected that safely from AC mains. And I'm more concentrating here on standing on the ladder than talking, so you have to excuse that. That's the low voltage side. Okay, got it. So, here's the culprit, the cause of all my troubles, the bane of my life. And I picked that up used in the neighborhood. Card here, link in the description. And I plan to replace that with that electronic transformer. But yeah, the devil is in the details. First, you note this is, and we will have a close-up in a second, 105 watts max, starting at 35 watts. So put some load on it, otherwise things get screwed up. This one here is 110 watts max. Both are on the secondary 11.5 watts AC, okay? But the difference, yeah, 5 watt more, much larger, okay? Also in the thickness, much larger, much more room to dissipate heat. So I must say there are some tiny bits of slots here which well, do not really allow air circulation, but they are there while this is almost completely sealed. But yeah, this has probably twice the internal volume than that thing. So this probably run quite hot, and it's certified. Well, let me zoom down. That thing should be in theory good for an environmental temperature of up to 45 degrees C. I never reached that here. It was at most maybe 33 degrees C. And at that temperature, with under full load, the surface of that thing can heat up to 90 degrees C. Yeah. The transformer replacing it, which is also not new, I also found it somewhere, okay, that is also good for an environmental temperature of 45 degrees C. However, because it's bigger, the surface temperature at maximum environmental temperature and maximum power output goes only up to 80 degrees C. Yeah, that's the advantage of making things a little bit bigger. Unlike that thing that came with that IKEA setup, this thing has actually real mounting holes, which is great for me because I can secure the mains AC cable properly, and I still have another hole left to hang it up again. Great. Okay, time to put that thing up again. The new thing, that is. And the big moment, I have no idea if I'm in the frame, but I'm plugging it in now. Ah, if everything went white right now, it's working. Let's take that thing apart now. Yeah, I don't know. Oh, screws. Okay, that's something new. Self-tapping, of course. And now, okay, a little snap in here. I don't know. Not really. So, what's the problem? Ah, okay, got it. Ah, okay. One circuit board. And any more screws holding that in? I don't see any. Okay. Let me zoom down. So, that's the Disk Electronic S105 DS105V.PCB. Yeah, that's the isolation area from the low voltage side here and the high voltage side. And besides that, I see here maybe 1, 2, 3 diodes and one bridge rectifier. And that's it. But it looks bad. Let me zoom in on that part here a little bit. So nothing looks especially damaged, but look at that soldering here. And they didn't clean up after soldering. And there's a little tranny or something that has seen definitely better times. So that thing, yeah, that just cooked off. And yeah, let's go all in here on that's a guy. I have seen a lot while tearing down stuff, but oh, come on. And on that side we have, yeah, that's the main transformer here, high voltage side, and then what we saw, that's the low voltage part on the other side. Remember, this is AC out, so no rectifying here at the output. These should be 2 class Y capacitors bridging the low voltage side to the high voltage side. For EMC suppression, we have 2 more inductors here and a lot more capacitors and stuff. Yeah, a little electrolytic, and these are actually 2 transistors. Yeah, I won't get them out, but yeah, they're there, and that's it. The question arises, how does that thing work at all without any chip? I mean, By the way, that little thing here is actually some kind of fuse. I don't see any thermal overload switch. I don't know if that is also a thermal fuse. Here is AC in, and that should go through the thermal fuse, some filtering properly, and then directly into the bridge rectifier on the other side. And here, that stretch here, these are the class Y capacitors. I think they are class Y. For EMC suppression, and here's another input filter capacitor, but this is also an input filter capacitor, and these are probably all input filter capacitors. So really what we need to do is I won't find the schematic for that thing, but at least something that explains the principle of operation. So I found a nice web page explaining those electronic lighting transformers. Link in the description, and there are also some photos. It's a little bit different. It's a rectangular format. Yeah, that thing doesn't look quite like we have. I mean, we have two heat sinks with two transistors properly, and they have here actually a thermal switch connected to one of the heat sinks. Didn't saw that in our model. Here is a photo of a circuit which is quite close to what we have. So we have the big transformer itself. We have a lot of capacitors here and resistors, and we have two more inductors. So that's already quite close. However, if you look at the circuit diagram here, that's, well, not exactly, but almost what we saw back there. So we have here our AC input, so mains AC, we have that filter capacitor, we had a fuse, we had a little inductor, we have the bridge rectifier, and remember we had 1, 2, 3 diodes on the back, so that matches exactly. And then you have two transistors. Yeah, I'm not going to explain that circuit now. But anyway, this forms an oscillator. This forms an oscillator, and just transfer. So we first transforming the 230 volts AC into filtered DC, and then we using that oscillator here to convert that again into a higher frequency AC. So we can use here a smaller transformer. So basically, if you put a rectifier and some output filtering here on the secondary side, you have kind of an unregulated switch mode power supply. And that's it. That's it for today. Sorry for not explaining that oscillator circuit here in detail, but we are already at 28 degrees again, and to be honest, I don't feel like it. But you can, yeah, read that article or Google it up for yourself. It's not that complicated of a circuit. Anyway, until next time, bye.